Alright, so we're looking at lesson 20 today. We're going to look at heat and specific heat. So hopefully after the lesson you'll understand heat and specific heat. Remember that kinetic energy of a molecule is the energy that the molecule has because of its motion. We talked about that several weeks ago. Temperature is the measure of the average internal kinetic energy of the molecules of your substance. So if something's really, really cold, it's going to have lower kinetic energy. As it heats up, it's going to have more kinetic energy. The closer it is to zero, the lower the kinetic energy. As it gets higher, it's going to have a larger kinetic energy. If we place two objects in contact whose average internal kinetic energies, their temperatures are different, energy is going to flow from the body whose molecules have the higher average kinetic energy to the one that has the lower. So if you put ice in warm water, the kinetic energy is going to flow from the water into the ice. And so it's going to make the ice have a higher kinetic energy, which is going to raise the temperature of the ice, which is why it will melt. In time, the energy transfer will be sufficient to make the average internal kinetic energies of your two equal. So eventually that cup of warm water won't be quite as warm. It'll be a little cooler because the ice will have brought the temperature down and the ice's temperature will have raised. So we call this type of transfer heat energy transfer, or just heat. Heat is not a measure of how hot or how cold a body is. So we don't talk about how hot or cold it is. It is not the average internal kinetic energy of the molecules of a body. Instead, heat is the energy in transit between two bodies whose temperatures are different. So it's what is happening in the between the two. The only cause of this energy transfer is that there's a difference in temperature of your two bodies. So there won't be a heat transfer unless there are two bodies that have different temperatures. We talked about James Prescott Joule a few lessons ago, and he showed that the change in temperature of bodies is caused by the friction. It's proportional to the quantity of mechanical energy expended. He also demonstrated that the temperature of 1 pound of water could be increased 1 Fahrenheit degree by the mechanical energy expended by the descent of a 1 pound weight through a distance of 772 feet. I'm not exactly sure how he demonstrated it, that it was exactly 772 feet, but somehow he did. Early measurements of heat energy were made in calories. I'm sure you have all heard of calories. The candy bar that you ate had 200 calories or whatever. The cereal that you consumed this morning had 130 calories, plus the milk that had 140 calories or whatever. You've heard of that term before. We define a calorie to be the amount of heat energy necessary to raise the temperature of 1 gram of water 1 Celsius degree. So 1 calorie equals 4.186 joules, and that's a number that you probably want to put on your formula sheet. 1 calorie is 4.186 joules. 1 food calorie, that's different than a calorie. So when they talk about food calories and calories, those are different. But a food calorie is 4,186 joules. So let's look at an example. A student eats a lunch that contains 800 food calories. How many times must he lift a 490 weight a distance of 2 meters to expend the same amount of energy? So we need to figure out how many joules that calorie is. So we're going to use our formula. 1 food calorie is the same as 4,186 joules. So they give us 800 food calories, and we need to multiply it so that we get it in terms of joules. So this is the unit multiplier we're going to use, except we're going to have to use the reciprocal of it because the food calories needs to be able to cancel out. And so 4186, and if you multiply you get 3,348,800 joules. And then it says, how many times must he lift that force a distance of 2 meters to expend the amount of energy that he consumed. So our work is equal to force times the distance, and our force is 490, and our distance is 2. So if you multiply those two together, you get 980. So that's the work he needs to do, and every time he lifts the weight, he uses 980 units of work, which is in joules. So then you're just going to take your 3,348,800 and divide it by the 980. And that comes up with 3,417. And we have 3 sig figs, so that's going to be 3,420. So how many times? That's how many times he has to lift it. And if you look at the book, they put it in scientific notation. I don't really care if you put it in scientific notation or not. That doesn't matter to me. Okay, so that's how you could use your formulas. Now we're going to look at specific heat. We use the symbol Q to represent the amount of heat that is transferred during a process. So if it takes 4,186 joules of heat to raise the temperature of 1 kilogram of water 1 degree Celsius. This constant is called the specific heat of water. So C sub water is your specific heat of water, and it is 4,186. And if you want to write it with J, kilograms, and C instead of writing out joules and Celsius, you can. And each element or substance is going to have a unique specific heat. And if you look in the book on page 115, it gives you a table of some of the most common ones. Sometimes it'll give it to you, sometimes you'll have to refer to the table. You can also look at the back of the book to find the table as well. So this is our formula we're going to use. Our heat energy is equal to the mass times the specific heat of whatever material you're working with, and then the change in temperature. Now, the change in temperature does have to be in either Celsius or Kelvins. Since Kelvin, you just add or subtract 273 to go from Celsius to Kelvins. You don't have to convert them to one or the other. But if you're in Fahrenheit, then you do have to convert it to Celsius to be able to plug it into this formula. So the C is what you'll look up in your chart. Alright, so let's look here. Find the amount of heat required to raise the temperature of 460 grams of silver from 273 kelvins to 300. So we're going to start with our formula. That's supposed to be a T. So we are looking for our Q. We need to find the mass, and the mass is always in kilograms, but they gave it to us in grams. So 1,000 grams is 1 kilogram. So I'm just going to move the decimal place 3 places. So I'll have 0.46. Now for silver, you need to look at your chart on page 115. And you should see silver on the right hand side, and it's 234. So So that's your C there. And then the change in your temperature, we went from 273 to 300. So that's a change of 27 degrees. So if you multiply, you should get 2,906.28. And we have 3 sig figs in all of our given numbers, so 2910. And heat is in joules. And so that would be your answer there. Okay, so make sure that you do your homework 1 through 20 and your curveball questions for homework so we can go over any questions you have tomorrow.